So timer and counting devices. A timer is a specialized type of clock which is used to measure time interval. A timer that counts from 0 upwards for measuring time. It's look like a stopwatch. It's starting 0, 1, 2, 3, 4, 5 like that. So timer is a device countdown from specified time interval. It is used to generate a time delay. Example for hourglass. What is hourglass? They're saying that's a sand glass, hourglass. So counter is a device that store and sometimes display the number of times a particular event or process occurred with respect to clock signal. Counter the number of time particular event or process occurred with respect to clock signal, that is called as counter. So this is used to count the events, how much event happening outside the microcontroller. The counter easily can implement, and this is used for used as a register type of circuit like flip flops like that. So what's the difference between timer and counter? The register timer is register incremented for every machine cycle, and counter register is incremented considering 1 to 0 transition. This is corresponding to external input pin. The maximum count rate is 1 by 12 of the oscillator. The maximum count rate is 1 by 24 of the oscillator frequency. A timer uses the frequency of the internal clock and it generates delay. A counter uses an external signal to count the pulses. Timers of 8051. The 8051 has two timers, timer 0 and timer 1. What is 8051? 8051 is a microcontroller. And 8051 has two timers, timer 0 and timer 1. They can be used as timer as an event counter, both timer 0 and timer 1. So see, timer 0 register is a 16-bit register accessed as a low and high bit. The low byte register is called as a TL0, timer 0 and 0 low byte, and higher byte register is called as TH0. So these register can be accessed like any other register. For example, the instruction MOV TL0 forget moves that values into the low byte. So you see there are 16-bit register is there. That 16-bit register splitted as T low, that means timer high and timer low. The timer low is TL0, timer high is TH0. So it started from 0 to 7 consider as a TL0, and 82 to D15 we can consider as a TH0. Timer 1 register. So similarly there is another register also in the 8051. So there are two registers, one is timer 0 and timer 1. Both are having 16-bit register. So timer 0 having TL0, TH0, and timer 1 also having 16-bit register. That is also splitted into two byte. One is lower byte, we can call as a TL1, and higher byte we can call as a TH1. So the previous one having the instruction named as move PL0 has 4 edges. Similarly, for TH1 the having the example of instruction move TL1 has 4 edges. So next one, T mode timer mode register. So it is a 8-bit register. The lower bit that lower bit set as a timer 0 and the higher upper bit set as a timer 1. So lower bit are lower nibble 0 to 0, that mode 0, mode 1, and clock and timer, then gate. So this parts we can call as a timer 0. Then similarly, that's a higher timer 1, same mode 1, mode 0, clock and timer and gate. So what is gate? Gate, every timer has a start and a stop. So the gate initiate the processing. That means it control the timer. That means it control the software using the instruction. So it can start and stop the program. The set B instruction is used to start it and stopped by clear instruction. That gate, the have instruction set B, it is used to start the program, then stopped by clear instruction. So a set B TR1, timer mode 1, and clear TR1 for timer 1. So these are the instruction for timer 1, and set B TR0 and CLR clear TR0 for timer 0. So there are two instructions that is for timer 1, and then the another two instructions that is for timer 0. The two instructions from timer 1 set TR1 and clear TR1. Similarly, set TR0 clear TR0, that is for timer 0. So mode 1, mode 2. So what is we have timer 0 and timer 1 having mode 1 and mode 2. So what is mode 1, mode 2? So if the mode 1 is 0, 0. So first of all, there's a 13-bit timer mode. If it is 0, 0. So 13-bit register consisting of 8-bit of TH1 and lowest 5-bit of TL1. So mode 0 operates as the same for the timer 0 as it is a timer 1. Mode 1, the 16-bit timer. Okay, so it commonly used to mode the fast. It's a 13-bit mode, except all 16-bit are used to TLX incrementer starting from 0 and maximum the value is 255. The timer may contain up to 65,536 distinction value. Overflow back to 0 to after 65,336 machine cycles. And timer mode 2. So mode 0, mode 1, mode 2, and mode 3. Mode 0 means 00, mode 1 01, mode 2 10, mode 3 11. And mode 2, 8-bit auto reload. So both the timer are registered configured as 8-bit counter TL1 and TL0 with automatic reload. The benefit of the auto reload mode is that you have the timer always contain the value from 200 to 255. And mode 3 11, the splitter mode. The splitter timer mode, when timer is 0, then placed as a mode 3, then become its two separate 8-bit timers. The timer 0 is TL0 and timer 1 for TH0. So both timer it count from 0 to 255 in case of overflow. So clock and timer, we know what is clock and timer, and reading timer. There are 16-bit register two ways, actual value and overflow. Uh, the time overflow means if the timer has reached the limit value, that is called as time overflow. Okay, so the timer overflow tcon register. So instead of that if tf is 0 set 1, the time 0 has overflowed. If tf1, that means set 1, the time 1 has considered as a overflow. Okay, thank you.